Hey everybody, thank you for coming today to our Tuesday webinar. So I'm glad everyone noticed the new time at 12 Eastern, which is our second week in a row doing this. Today we are going to cover quadratic equations. Now in the past we've done a little bit of quadratics with everyone here on especially difference of squares, which we will be getting at today, I'm sure a little bit, and I know Scott likes to teach that topic. For what I want to do, though, is I want to start out, at least initially, just talking about, a general quadratic equation that everyone is used to, and then kind of adding layers to it as we move forward. So I'm sure most of you here, if I were to give you a quadratic equation like x squared minus x minus 12 is 0, and I wanted you to solve for x, you could certainly factor this down. And this is a quadratic equation in the most traditional sense. It's what, I remember learning even back in middle school, and I'm sure many of you do as well. And, if we're factoring this down for anyone who has potentially forgotten, the goal when creating these parentheses as we factor this down is we're finding two numbers that will multiply to negative 12 and two numbers that will sum to a minus 1. Notice there's a minus in front of the x, which represents a minus 1. So when we do that, we say, okay, well, the two numbers that are going to do that are x minus 4 and x plus 3. Now, if we were to FOIL these two parentheses, we would actually have what we started with. That's a way to affirm that what you did in these parentheses is correct. And then the final step, of course, is using something that we talked about in our quadratics chapter, chapter 3, which is the zero product property. And what that is taking each parenthesis, it's called parenthesis 1 and parenthesis 2, and then just setting it equal to 0. Now, of course, you can do this part in your head where you have x is 4, and you can do this part in your head where x ends up being negative 3. The reason we're going through this is what I want everyone to see and notice is that the GMAT is not always going to give you things in this nice, neat form that we're all used to. So what they'll do is they'll add in variables, they'll add in little components to kind of layer in the question to make it a bit more difficult. But if we can kind of stick to our processes, as we always talk about, we can be very successful dealing with these questions. So the first question I want everyone to try, and we'll give everyone 2 minutes for it, is a question that is dealing with what appears to be a quadratic equation, but you'll notice that we're dealing with a constant. So I want to see what everyone does here. If you can, put your answer in the public chat box when you have it, and I'll give everyone 2 minutes to try it out. Okay, so that was about 2 minutes there. So the first thing that's interesting, and I do this problem with students a lot, and one of the biggest mistakes that they make right off the bat is they don't really know what to do with the -2. I mean, even if you set this up like we want this in the general form of a quadratic equation where you set everything to 0, and even if you start trying to make parentheses, what you're going to realize is that you still have two variables. And what made this so nice and easy to solve, this x squared minus x minus 12, is that we were only dealing with one variable x. So since that sounds like such a comfortable place to be, you want to do your best to get back to that place where you feel very, very comfortable. And the only way to do that is to figure out what n is and what that constant is. Now, if you're wondering why -2 is not n, it's because when you first read the question, it says that -2 is actually a solution. It's not a constant. And the way that we know we're dealing with a solution is that down here in the question I showed you originally, these values of x, those are actually solutions. So knowing that, we can say that x actually equals -2. And the beauty of that is that we can now take -2 and we can sub it in for x and we can sub it in for x. So by doing that, we have -2 squared minus 6 times a, use a parenthesis there, times a -2 times an x minus 40 equals 0. So we see that when we do the math there, we can end up getting a value for n. So we see we have a +4 plus 12x minus 40 is 0. So what we want to do here is we want to combine. So we can combine the 40 and the 4. We get 12x minus 36 is 0. We get 12x equals 36. Finally, x is, or excuse me, I plugged in and that should have actually been an n. So I apologize for that. Let me fix that. That's an n. That's an n. That's an n. There we go. So what we actually get is that n is 3. So what we've done here is we have solved for the constant. Now, in a perfect world, we'd be done, but of course, this is the GMAT, and they're going to force us to do more work. So the next thing says, which of the following could be a product of n and x? Now, the trap here is to say, well, I have an n equals 3, and I have an x equals -2, so maybe the answer is C, because maybe I did something wrong. Maybe n should have been a -3, and -3 times -2 is 6. Well, it turns out that that is, in fact, a trap, because the math that we've done up to this point is good. And again, this is just what happens on more challenging GMAT questions. So we always want to be careful that we're finishing the question out. And the only way to finish this question out is to plug in our value of n and get a regular quadratic. Now, we can scroll down, actually, and we have, if we plug n as 3, we get x squared minus 18x minus 40 is 0. Now, this is somewhat awkward of a quadratic, but, you know, if you really think about it, you see that we have x minus 20, x plus 2 equals 0, so x equals 20, and of course, we already knew x could be -2. So the possible value of n times x, we scroll back up to the top of the answer choices, is going to be 20 times our value here. Well, let me scroll down and pull these up. We have x is 20 and x is -2, and we need our value of n, so sorry, n is 3. So our possible values are going to be 20 times 3, which is 60. So, of course, this problem had many layers. You know, the biggest piece of advice I can give you, and this goes beyond just quadratic questions, but focusing on this question for a moment, we know n is a constant. It's there for a reason. The reason generally is you need to solve for that value of n and then do something with it. There are plenty of other questions out there. You'll even see some in the official guide, which I'm sure a lot of you have practiced with, where you know, you see n has a constant and you have to solve for it and do something else. So keep an eye out for when you see, you know, blank as a constant. Know that you have to solve for it and you're going to have to use it moving forward to be able to solve different types of questions on this test. Now, the next thing I want to talk to everyone about before we get into the next question is other types of quadratic equations. And another one that I really like to give students is if you have x squared equals 64x and you need to solve or get a value for x, how would you do that? Now, I have some students that right off the bat will say, oh, that's easy. X equals plus or minus 8. And I say, well, that's not necessarily the case. It would be the case if we have x squared equals 64, but you'll notice you have an x squared equals 64x. So that's out. Another common trap is to say, well, I'm going to divide everything by x. Well, although that seems like you should be able to do that, the issue is that if x were 0 and you divided by x, you would actually create an undefined equation. So that leaves us with one other possibility, and if we treat this like we treat many quadratics, well, what do? We set them to 0, and we factor out. And what we'll notice here is that there's a common term of x that we can pull out, create parentheses, and once again use that fun rule, the zero product property that I mentioned earlier. And what we'll do is highlight each component of our product. And the one thing you can't forget is that the little x on the outside counts, meaning we have to take that and set it to 0, just like we have to take this and set it to 0. And lo and behold, our values are x is 0 or x is 64. So what I want to do now is I want to get into a few practice questions, or at least one kind of testing this idea. So let's take a stab at this here, and I'll give everyone 2 minutes again. Okay, so that was about 2 minutes as well. This question, clearly I had talked about a couple traps before, and this question is definitely testing those traps, especially when you look at statement 1. Another key point, make sure, you're always honed in on the given information. Notice we have x being greater than or equal to 0, so we may need to use that, kind of moving down the line in this question. But the first thing you want to avoid here is you 110% want to avoid dividing equation 1 by x to the second power. If you do that, again, x could be 0, so we potentially could be creating an undefined equation by doing that. So instead, we move it over, and again, this is all being very systematic. We set to 0, and we say, okay, what's the biggest value of x that I can pull out? In the last problem, x was the biggest value of x, but in this problem, you'll notice that x squared is the biggest value that can be pulled out. So it gives us x squared minus 4 equals 0. So the next thing we can do here is we can say x squared times x plus 2, x minus 2. That's a little bit of the difference of squares there. And we can set this whole thing to 0. And finally, we can use, and I'm sorry, this needs to be x squared minus 16. That's plus minus 4. So finally, we can use the zero product property again. Now, keep in mind the zero product property, it doesn't matter how many values you have in your product or how many terms, you still need to take each term and set it to 0. So we have, for instance, x squared equals 0, where x is 0, or x plus 4 is 0, where x is minus 4, or x minus 4 is 0, where x is a positive 4. Now, what's really interesting about this question is that had the given information been slightly different, statement 1 could have been sufficient. So we are seeing that x is greater than or equal to 0. Now, what that means is that this is a possibility, and this is a possibility. This negative 4 is, of course, not. But what if the given said x is greater than 0? Well, guess what? The only option that would have worked is 4. So again, this is a little bit of a side note, but this just goes to show how seeing and comprehending the details of a given data sufficiency question are incredibly important, and you never want to skip over the given information entirely or read through it or rush through it. Always write it down, always internalize it. I know it's a timed exam, and I know you feel like you need to do things quickly, but remember, if you do things too quickly, that's where mistakes start to happen. So be really, really careful about that. So back to the question, we see that statement 1 is not going to be enough information. Statement 2, hopefully you all notice we're dealing with a kind of general quadratic here. So we have x squared minus 8x plus 16 is 0. This means that we can have x minus 4 times x minus 4 is 0. X is 4 in both instances, so that's enough information. We do talk about this in our equation traps chapter, which is part of the linear and quadratic equations chapter. Never make the assumption that a quadratic is always going to give you 2 values. It's easy to look at it and say, oh yeah, quadratic's 2 values, that's how it always works. But in certain cases, that's not the case, and we saw this with answer choice 2 here. So if you by accident made a leap or a jump, just saying statement 2 was insufficient, really watch yourself there. Now, the next thing I want to talk about, it's a little bit of factoring. This also is towards the tail end of our quadratics chapter. It's called factor by grouping, and it's a pretty interesting component of the exam. Since we know this is an exam tested on high school math, I can say at least for myself that this is not something I ever remember doing in high school, but yet it's definitely something that the GMAT likes to test at higher levels. So what I'm going to do is throw up an example of this, and then we can all go through it, and then we'll do a few more questions, and I can hand things over to Scott. So I'll give everyone about 2 minutes to work on this one here. Okay, so that was about 2 minutes here. So what you'll notice here is that you have an x term here, an x term here, an x term here. Now, if you go ahead and you factor out an x and leave the 16 by itself, you'll find that you're going to hit a bit of a roadblock here. So instead, what we're going to do is we're going to actually break this up into 2 pieces. And by doing that, we're going to put ourselves in a position where we can factor out and then actually factor out again. So what we're doing is we're actually factoring out twice here. So the first thing that we can pull out from this is an x squared, and that gives us x minus 1. And then from the second set here, we can actually pull out a minus 16, and that also gives us an x minus 1. And of course, it's set equal to 0. Well, now what we'll notice is that we have common term of x minus 1 in both instances here. So we have x squared minus 1 as a common term, which we can then factor out again, and we have this. And of course, using the difference of squares, we get an x minus 4, x plus 4, put a parenthesis here, we see our values of x are possibly 1, -4, we'll start with +4 actually, or -4. Now it's asking for us to sum those together. We see these two cancel, and so the actual sum is just 1. Canceling means they set to 0. So that was a pretty good array of questions from Quadratic. Scott's going to probably get into some more challenging ones and potentially use some different squares stuff. But, you know, we have a ton of these questions, so for those in the curriculum, if some of this was reviewed, great. If you felt like you struggled with it, dive back in, do some practice questions, and of course, you know, see how you do and see how you score. So, Scott, here is the ball, and you can get moving.
Great. How's the audio, Jeff?
Perfect.
Okay, great. Hey, everybody. Good morning. Thanks so much for coming. What we're going to do here in the second half of the hour is do some different types of quadratics. We're going to do some different squares and some other interesting things. But I want to start off by showing you, interestingly, if someone said, you know, what's the most important thing you could teach me about data sufficiency that actually really has value, you know, not all of the nonsense that you hear about data sufficiency, but something probably none of you have ever heard before that has a tremendous amount of value in the way you approach these, it would center around this question. And I just got that email a couple hours ago from a student, so it's good timing for all of you. So you're going to try it first. We're going to go over the question itself, then I'm going to tell you what I think is the most important thing to understand about data sufficiency. And if you listen carefully, I think it's going to be pretty eye-opening for many of you. So remember, guys, our quest is for simplicity. On the test, you'll always, don't start yet, by the way. On the test, you'll always have the opportunity to make things more complex, and should you do that, caveat emptor, right, means let the buyer beware. Don't do that. Your goal is to make things more simple, never more complex. Okay, so let's give this a whirl. Let's take about 2 or 3 minutes starting now, and then we're going to talk about some pretty interesting stuff. Let's go ahead. Okay, guys, so that's a little bit about 3 minutes or so. So this is a really important question. A, because it tests some important sort of hard math skills that you have to know, but as I told you, B, because it's going to show you something that I always want you to carry with you forevermore, at least forevermore when you're studying for the GMAT and taking the test. So it says if n is an integer, is n cubed minus n over x an integer, right? So most of you realize at this point that your key first sort of tactical move here is to factor out the n in the numerator, right? We have a common term. So if we have n cubed minus n over x, you know, most of you at this point see that we can pull out the common term, which is the n. And within parentheses, we're left with n squared minus 1. And, of course, this is all still divided by x. Well, n squared minus 1, in light of the fact that we're talking about quadratics, that's a really important quadratic called the difference of squares, right? Remember, difference of squares says that a squared minus b squared is always equal to a plus b times a minus b, and you have to be on the lookout for that guy at all times. You may see it once or twice, you may not see it at all, but on average it's something that's really important to be on the lookout for. So what we can see here is, so n squared minus 1, well, that's the same thing as n squared minus 1 squared. So if you see here, that's in the form of a difference of squares. So what we can do is we can re-express the numerator again as n times n minus 1 times n plus 1 over x. And we're asking ourselves, is this an integer here? Okay, so again, as Jeff told you, it's really important that you perform as many operations as you possibly can on the given information and data sufficiency, because quite often, you know, working the information given in the STEM, the stimulus, is just as important as working on the statements. So let's go to statement 1. So x is equal to 6. So let's put x in as 6. We'll get rid of the x here for a sec, and we'll put in 6. And the question is that sufficient to answer the question? And if you said that it is, good for you. Most people say that it's not. Now, let's talk about the reason why statement 1 alone is sufficient. Well, if you look at the numerator, and if we rewrite it a little bit, what we see is we have n multiplied by n minus 1 multiplied by n plus 1. And you guys might have to scroll down a bit because I'm a little bit lower on the screen. But what we can see here, guys, is that we have the product of 3 consecutive integers. Right? We don't know which integers, but for example, this could be 5, this could be 6, this could be 4, this could be 2, this could be 3, this could be 4, this could be 100, this could be 101, this could be 102. It doesn't matter what they are, but you have to recognize that n minus 1 times n plus 1 represents the product of 3 consecutive integers. Now, there's 2 ways to proceed from here. I think it's a handy rule to remember that the product of any 3 consecutive integers is always divisible by 6. For example, we can look at case A here, right? 4 times 5 times 6 is definitely divisible by 6. We could look at case B here. 2 times 3 times 4 is definitely divisible by 6. This one's going to skip C. I mean, we could prime factorize it and see that's divisible by 6, but it's not the best example. We could do like 18, 19, 20 instead. We can see that 18 times 19 times 20, that's divisible by 6. So the product of any 3 consecutive integers is always going to be divisible by 6, because try as we may to not do this, we're always going to cross at least 1, 2, and at least 1, 3. And if we cross 1, 2, and 1, 3, we know that we have a power of 6 at least 1. So therefore, it will be divisible by 6. So actually, statement 1 alone is sufficient. So we'll say AD, BCE, we'll cross off B, C, and E. And now we'll look at statement 2. So interestingly, knowing that n equals 2 doesn't tell us anything because what's the value of x, right? So, for example, looking at statement 2, to know that n is equal to 2, well, I'm going to do it on the corner right over here. Well, we'd have 6 over x, right? And what's the value of x? We have no idea. Okay, so the answer here is actually A, which to some of you probably seems a little bit shocking, and whether it's shocking to you or not, what I'm going to tell you now is really, really, really valuable wisdom. So just listen carefully to this. So, and these are not my ideas. These are ideas of researchers in the forefront of cognitive science. A lot of this is actually Nobel Prize winning work. So I can't take credit for any of this. And if you're interested in the books or the articles, you can always email me. I'd be more than happy to give them to you. But, you know, researchers believe that the brain has 2 primary pathways through which it thinks. And I promise you this is highly valuable, so listen carefully. So I'm going to go to a different slide. So the brain uses what's called a type 1 pathway and a type 2 pathway. This is ultimately applicable to data sufficiency questions. In a type 1 pathway, it's really fast. It's really low energy. It makes broad, sweeping generalizations. It stereotypes, right? It makes generalizations. It does things very quickly, very almost instinctually, and it doesn't use much energy. So it's really comfortable to use this type 1 pathway of the brain. It's really comfortable, and you'll see what I mean in a second. Now, a type 2 pathway is really slow, relatively speaking. It requires lots of energy. It requires lots of concentration. It doesn't make stereotypes. It doesn't make generalizations. It analyzes data specifically, meaning it looks at the data for what it is and it asks complex questions. Now, it's painful to use the type 2 part of the brain. So anytime you've been ultimately focused on an algebra problem, you're using type 2. Anytime you are carefully analyzing a complex spreadsheet in Excel, you're using type 2. Now, type 1 is like you're walking in Texas and you hear a rattle behind a bush and you jump. Why did I pick Texas? Well, I know there's rattlesnakes there. I guess I could have picked California too, but, you know, the place where there's rattlesnakes, you hear a rattle and you jump. Well, the brain says, wow, that's a rattlesnake. And you know what? Even if it's wrong, you didn't lose anything. So this evolved in humans as a protective mechanism, right? You didn't have to think about it. You didn't have to put much energy into it. You heard that rattle behind the bush and you jumped. I would jump. Most of you would jump, okay? So the risk of not jumping is infinitely higher than the risk of jumping and being wrong, right? So this is crazy, but maybe it's a baby shaking a toy and he needs your help, right? Well, type 1 doesn't think like that. Type 1 says, you know what, I'm in the mountains and there are rattlesnakes here and I hear a rattle, God damn it, I'm jumping. Okay, so there's a purpose for type 1. Type 2 would not kick in there because type 2, you'd have to sit there, you'd have to say, is this a rattlesnake? Do rattlesnakes come out this time of year? Is this the proper temperature? Did we have enough rainfall for rattlesnakes? Is this altitude the right altitude for rattlesnakes? Maybe it's a snake that has a rattle that doesn't really have venom, so it's not a big deal. Type 2 would never work in that situation, okay? Here's the problem, guys. Here's the important punchline. In today's world, there's not that many times where lions are chasing us or rattlesnakes are about to bite us or there's great white sharks swimming below us, right, unless you purposely put yourself in those situations. But in the world of math and economics and finance and business, people who consistently use type 1 pathways are always at the end of the line when it comes to success, because the world today is not built on using the type 1 mechanism of your brain. The world is absolutely built on using the type 2 mechanism of your brain. And people who are willing to focus and put the energy in and not make hasty conclusions are those who are going to be rewarded today and likely in the future, because it's not getting any more simple, it's getting more complex. Right, so why is this so important and why did I bring you through this story? Well, if you come back to the problem, if you take most sort of unsophisticated GMAT takers or studiers, they're going to tell you that the answer choice is C. And what they're doing is they're making a type 1 error. They're not properly engaging the right brain muscles to analyze the story carefully enough. They're saying the world is a simple place. I need to know N. I need to know X. If I know N, I know X, I can answer the question. You can see, though, when you actually use the type 2 mechanism, which is the logic I use to carry you through this problem, you know, it's not simple. I mean, even I've done this problem 1,000 times. It still required me to think about it. It still required me to exercise care and diligence and really focus. So if you picked C, you made a type 1 error. If you picked A, you properly engaged the type 2 region of your brain. You have to remember this going forward. Nothing is simple on the test. Don't fall for their traps. They will always give you the opportunity on data sufficiency questions to produce a type 1 error. You have to get away from that knee-jerk reaction that your brain loves to do, and you have to get into the habit of analyzing things with a lot of gusto and a lot of focus. Okay, now there's a lot more I could tell you about that, which would help tremendously, but we're limited on time here this morning. But that is the most valuable thing I could tell you about data sufficiency questions, because the advice I just gave you and the knowledge is broad sweeping, and it can be applied to any data sufficiency question. So with that said, I want to give you the opportunity to either continue your winning streak or to redeem yourself if you got this question wrong. And it doesn't mean it's going to be 100% easy, but what it means now is you're a little bit better equipped to handle it. So let's give this a whirl. I'll give you about 3 minutes, and let's see how you do. Let's see if the last problem and your new knowledge allows you to circumnavigate any data sufficiency traps. Okay, guys. Good. So I see that actually more of you answered or getting this one right. And it doesn't mean that, some of you got it wrong. That's okay. Still not easy. It's just, obviously you've just been exposed to this a couple of minutes ago, but let's give this a whirl, keeping in mind what we just spoke about. So x and n are even positive integers. We want to know, is x divisible by both 2 and 3? So in other words, is x divisible by 6, right? Either way you want to look at it. So statement 1, so if x is equal to n cubed plus 6n squared plus 8n, of course, what we're going to do here is default back to our best practices, one of which is to factor out common terms. So the greatest common factor here is n. That will leave us with n squared plus 6n plus 8. And of course, we see that we have a quadratic here. We can factor this to n plus 2 times n plus 4. And that's about as far down as we can go. Now, remember, type 1 immediately says, well, definitely insufficient, right? We don't know anything about x. We don't know anything about n other than that they're even integers, right? So type 1 here will say, you know what, Scott, move on. This is easy. You got this. Why even think about it? It's nothing to think about. Let's move on, right? It's not sufficient. However, that was easy. It was too easy, right? So if we kick the type 2 system into place, what we have to recognize here is that this is a pattern, and this is a pattern that we have to know, first of all, then recognize. And of course, the pattern is this is the multiplication of 3 consecutive even integers, right? So n times n plus 2 times n plus 4, right? N is even here. We're talking about the multiplication of 3 consecutive even integers. Now, you can memorize the rule that this will always divisible by 6, or if you didn't know the rule, you could try some numbers. You could say like 2, 4, 6. Well, that's divisible by 2 and 3. 4, 6, 8. That's divisible by 2 and 3. 8, 10, 12. That's divisible by 2 and 3. So interestingly, maybe a little bit paradoxically, statement 1 alone is sufficient, because we get a resounding and conclusive yes, x is divisible by both 2 and 3, because x can be expressed as the multiplication of 3 consecutive even integers. So we'll say A, D, B, C, E. So B and C and E are out. So again, it takes effort to think like that, right? It takes effort to not just follow a knee-jerk reaction and to actually really put your brain into gear and focus on this. Let's look at statement 2. I'll do that in green. So it says that x is equal to n cubed minus 4n. We'll go to the same best practice here. We'll factor out the common factor of the n. With n squared minus 4, that's difference of squares, right? So we have n times n minus 2 times n plus 2. Now, this one's a little bit harder to see, but if we reorganize the terms here, what we can see is x is equal to n minus 2 times n plus 2, and because the n is even, this is also representing the multiplication of 3 consecutive even integers, right? This could be 2, this could be 4, this could be 6, right? This could be 10, this could be 12, this could be 14. Okay, so type 1 will say, no way it's sufficient, right? We don't know x and we don't know n, so there's no way that this is going to be sufficient. Type 2 has to kick in, and it has to look more carefully, look for patterns, look for trends, look for known relationships. And type 2 says, well, if x can be expressed as the product of 3 consecutive even integers, and if the product of 3 consecutive even integers is always divisible by 6, well, then it's always divisible by 2 and 3, and statement 2 alone is also sufficient. So what we can see here then is the correct answer is D. And I'm glad to see that more of you actually got that correct. So in general, guys, what you want to do is always make this stuff more simple, never make it more complex. Follow standard operating procedures. You know, for those of you who are using our curriculum, you're already building the right skills. I say this every webinar. If you're not, and you're not getting the results you want, you should really ask yourself, why are you using the materials that you are? Our stuff is ultimately robust, amazing material, lots of practice, very clear, lots of strategies. So with that, guys, I don't have anything else for you. If you have any questions, as always, you can send me an email. You can Skype me, whatever you like. Otherwise, we'll look forward to seeing you guys back here at the same place, same time next week. And we appreciate y'all coming.